Assalamualaikum and a very good morning, evening, or night to everyone who is hearing this and whenever you are hearing this. My name is Muhammad Hafiz Haiqal bin Muhammad NASRI from class Mathematics 1, August 2025 intake. Today, I'm gonna be presenting to you about solving real-world problems using algebra. So, the contents of my presentation today will include introductions to algebra and also an example of a real world problem that we are going to solve. And also, it includes some subtopic contents that we will use to solve the real problems, which is linear inequality, absolute value, linear equation, and also linear programming. Okay, now we will start with the introduction to algebra. Algebra is often called the language of mathematics. It is a branch of mathematics that generalizes arithmetic by using symbols, like letters such as x and y, to represent unknowns or unspecified quantities, which is often called variables. Algebra, instead of working only with numbers, algebra lets us use symbols and equations to describe real-life problems. It's not just about solving x and y. It's about understanding relationships and making smart decisions. Algebra is often used in business, science, technology, and daily decisions, whether it is calculating profits, managing resources, or planning future goals. Algebra will help us turn those complex problems into clear, step-by-step solutions. So, in this presentation, I will show you how algebra connects to real-world situation and helps us make better choices through logical thinking. So, how exactly does algebra solve our real-world problem? Algebra is more than just solving for x. It is a tool that we use to solve real-world problems. Firstly, algebra helps us model real-world situation by turning real-life data or descriptions into mathematical equations. For example, a business can represent the cost of their products and also the profits of their products using equations to find the best-selling price for the products they are making. Next, algebra helps us to find the unknown values, like how long a journey will take or how much material is needed for construction. Next, algebra also lets us optimize results, such as maximizing profit or minimizing production costs through methods like linear programming. Using algebra, we can also make predictions. For example, we use quadratic equations to estimate growth or decline. We forecast trends or outcomes using mathematical relationships. And finally, support our decision making. Algebra strengthens decision making because it gives logical and data-based answers instead of guesses. That's why algebra is used in so many fields, such as business, science, and engineering, and even in daily life decisions. In this project, our real-world problems focuses on a food production company that produces two products, which is a standard box meals and also premium box meal. Each product requires limited amounts of rice, chicken, and also vegetables as raw materials. The company's goal is to find the best production plan that maximizes total profit while also staying within the available resource. At the same time, the company want to keep the production balanced, which means there is no extreme differences between the production of standard box meals and also premium box meals. So, as a manager of the company, we are required to design the most profitable amount of standard and premium box meals to produce without exceeding resources limits and also keeping the production fair and balanced between both products. Using algebra, especially linear inequalities, absolute value, linear equations, and also linear programming, we will model these entire situations or real-world problems mathematically, and we will determine the optimal solutions for this problem. The first subtopic content that we will be focusing on today is linear inequality, which plays a major role in solving our real-world problems. Linear inequality is a mathematical expression that compares two expressions using an inequality symbol, which is more than, less than, more than or equal to, or less than or equal to. So, the problems that we have right now is to ensure that the resources are not overused, the company must limit the amount of rice, vegetables, and chicken used. Each standard meal requires 0.5 kg of rice, 0.2 kg of vegetables, and also 1 piece of chicken, while each premium meal requires 0.8 kg of rice, 0.3 kg of vegetables, and also 1.5 piece of chicken. The company has 100 kg of rice, 25 kg of vegetables, and also 120 pieces of chicken available daily. To solve this problem, we must first formulate the model. First, we let the standard meal equal to X and the premium meal equal to Y. So now we have the variables in place. Let's translate or express the constraints that is given into linear equations. For the first linear inequality, we got rice, which is 0.5 for the standard meal and also 0.8 for the premium meal. So the equations will be 0.5x plus 0.8y will be less than or equal to 100. For the chicken, we got 1 piece of chicken for the standard meal and also 1.5 piece of chicken for the premium meal. So our linear inequality will be x plus 1.5y will be less than or equal to 120. And lastly, for the vegetables, we got 0.2 kg of vegetables for the standard meal and also 0.3 kg of vegetables for the premium meal. So our linear inequality will be 0.2x plus 0.3y will be less than or equal to 25. And also to ensure that there will be no negative value of meals that is produced by the company, we will also include non-negativity constraints, which is X, the standard meal, must be more than or equal to 0, and also Y, which is the premium meal, must also be more than or equal to 0. These inequalities will help us understand how many standard meal and also premium meals that can be produced without exceeding the available daily resources. When we plot this inequality on a graph, The overlapping shaded area shows the feasible region, which is the set of all production combinations that meet every resources constraint. This is the area where our real-world solution must exist. So, for the second subtopic content that we will use to solve our real-world problem is absolute value. Absolute value is a non-negative value of a number, regardless of its sign, and absolute value can be understood as its distance from 0 on a number line. So, the problem which involves absolute value is to maintain fair production and balanced workload, the company wants the difference between the number of standard meals and also premium meals to be no more than 30. To solve the problems that we are facing, we must convert the fairness rule into an absolute value inequality. So the equations will be modulus x minus y will be less than or equal to 30. The absolute value will ensure that whether the difference is positive or negative, it does not exceed 30. In solving this absolute value inequality, it is expressed as two linear inequalities, which is x minus y less than or equal to 30, and also y minus x will be less than or equal to 30. And by applying these constraints into the graph that we got earlier, we will have an even smaller feasible region, which is the difference between the standard meal and also the premium meals must be no more than 30. For the third subtopic content that we will use to solve our real-world problems is linear equation. Linear equation is an algebraic equation where each variable has an exponent of 1 and no variables are multiplied together, resulting in a constant or straight line when graphed. So, the problems that we have that requires linear equation is once all the inequalities are set, the boundary lines where inequalities become equalities are represented by linear equations. We can get the corner points of the feasible regions, and these corner points are essential because maximum profit occurs at one of them. So we are required to find the corner points of the feasible regions. So to solve the problems of finding the corner points, we need to identify the corner points first, which is for now we have two corner points, which is point A and point B. Point A is located on the intersection of line X plus 1.5y equal to 120, which is the chicken line, and also the line X minus y equal to 30. And for point B, it is located on the intersection of line X plus 1.5 equal to 120, which is also the chicken line, and also line Y minus X equal to 30. To find the coordinate for point A, we must first write down the equations that we have, which is x plus 1.5y equal to 120, and also the second equation is x minus y equal to 30. So we can rearrange our second equation into x equal to y plus 30. And then we substitute the equations that we have rearranged into equation 1. And we have in bracket y plus 30, and we close the bracket, and then plus 1.5y equal to 120. Then we expand the bracket, and then we solve the equation. We got 2.5y plus 30 equal to 120. And then we minus 30 from both sides, and we got 2.5y equal to 90. And then we divide by 2.5 from each side, and we got y equal to 36. And then once we got the value of y, we can substitute the value of y into the second equation, which is x equal to y plus 30. So y equal to 36, and then we got x equal to 36 plus 30, which is 66. So the coordinate for point A is 66 and 36. To solve for point B, we need to first write down the equations that we got, which is x plus 1.5y equal to 120, and also y minus x equal to 30. The same from before, we rearrange our equation into y equal to x plus 30, which will be our second equation. So we substitute our second equation into the first equation, and we got x plus 1.5 and in bracket x plus 30 equal to 120. So we expand the bracket, and we got x plus 1.5x plus 45 equal to 120. So we add up the x and also minus 45 from each side, and we got 2.5x equal to 75. Then we divide both sides by 2.5, and we got the value of x, which is 30. And then we the value of x, we substitute the value of x into the second equation, which is y equal to x plus 30, and x equal to 30. So we got 30 plus 30, which is 60. So the value of y is 60. Then we got the coordinate for point B, which is 30 and 60. And for the last subtopic content that we will use to solve our real-world problem is linear programming. Linear programming is a mathematical method used to find the best possible outcome, such as the maximum profit or the minimum cost, in a system where goals and constraints are all linear relationships. So the problems that we have right now is each standard box meal earns 8 ringgit of profit, and each premium box meal earns 12 ringgit of profit. So the company wants to determine how many of each meal to produce and to maximize the total profit without violating resources and also the fairness constraints. So to solve these problems, which is we want to maximize the profits that we gain from selling the standard meals and also premium meals, we must find the objective function for the linear programming. So the objective function is P equal to 8x plus 12y. 8 we got from the profit of standard meal, and 12 we got from the profit of premium meals. So using the corner points that we have calculated before, we will insert both of the variables into the objective function to get the maximum profit. So using point A, we will insert both of the variables into our equation that we got earlier, which is 8x plus 12y, and we got 8 times 66 plus 12 times 36. When we expand the brackets, we will got 528 plus 432. Then we got the final answer, which is 960. So the maximum profit that can be earned by that company is 960 ringgit if they produce 66 standard meals and 36 premium meals daily. And if we use point B into our equation, we will get 8 times 30 plus 12 times 60, which is when we expand the equation, we will got 240 plus 720, which is also 960. So the maximum profit that can be earned by the company is 960 ringgit if they produce 30 standard meals and 60 premium meals daily. So this shows how linear programming combines all algebraic methods we've learned earlier, which is linear inequalities, linear equations, and also absolute value to solve our complex real-world problems efficiently. It allows us, the decision makers, to maximize our output and use our resources wisely. So, throughout this research, we've seen how algebra is not just about solving numbers. It is about making real-world decisions. Using linear inequalities, we modeled our company's resources and limits. Through absolute value, we ensured that the production remains balanced. Through linear inequalities, we can find the maximum amount of standard meals and also premium meals that can be produced daily. And also through the linear programming, we can determine the most profitable combinations of those meals. And from our findings, we find out that both of the points will produce the maximum amount of profits that can be earned daily. And hypothetically, all the amount of standard meals and also premium meals on the constraints of chicken line will produce the maximum amount of profits that can be earned daily by the company. But we use point A and point B because it is the most easy one to complete. So in conclusions, these projects truly demonstrate mathematical modeling using algebra is more than just a theory. It's a powerful tool for solving problems, optimizing outcomes, and also guiding smart business strategies. It strengthens our logical thinking, decision making, and also the ability to apply mathematics meaningfully in real life problems. That's all from me. Thank you.